Okay, 2.7. We're going to be able to graph our rational functions, but we need to be able to graph them by hand without our calculator. So in order to find the y-intercept, we find where the x is 0 and then plot it. We set the numerator equal to 0 and solve it so that we can find the x-intercepts. We set the denominator equal to 0 and solve because this will give us our vertical asymptote. We find and sketch the horizontal based on the degree of the functions. We're going to plot at least 1 point between and 1 point beyond each intercept and vertical asymptote. And we're going to use smooth curves to connect it and complete our graph. We're going to test for symmetry with respect to the y-axis and to the origin. And graphing calculators do have a difficulty. So sometimes it's easier to change it to dot mode. Sometimes that helps. It's up to you if you want to do that. So here we are, we're going to start sketching the graph of 3 over x minus 2. And we're going to do this by hand without our calculators. Alright, so we're going to start with what is the y-intercept. The y-intercept means x's are 0. So 3 over 0 minus 2 means y is negative 3 halves. That is a y-intercept. So negative 1 1/2. The x-intercept is based on the numerator equal to 0. So none. There is no x-intercept. The vertical asymptote is the denominator equal to 0. So the vertical asymptote is when x is 2. So I'm going to come up here at 2, and again our asymptotes are usually dashed lines. Horizontal asymptote is based on the degree. The degree of the numerator is 0, and that is less than the degree of the denominator, which is 1, because it's 0 up here, x is 1. And if it's less than, numerator is less than the denominator, we know that the asymptote is y is 0. So that's our x-axis here. And then we need to have some additional points. And we're going to pick easy points here. I'm going to pick negative 1, because if I put in 3 over negative 1 minus 2, well, that's 3 over negative 3 for negative 1. Negative 1 is negative 1. So there's my intercept, so I'm going to pick 1 on each side of my intercept, so I'm going to pick positive 1. I know what 0 is because I found it. Positive 1 is 1 minus 2, so 3 over negative 1 is negative 3. Alright, so that clearly shows me how I'm approaching my asymptotes. Alright, now I need to pick some points on the other side of my asymptote. Generally, our graphs are diagonal from each other. I would say 95% of the time. But there is always those occasions where they're next to each other, or on top of each other. But generally, if we see that this is going to be down here in kind of quadrant 3 of our graph, the other piece is going to be up here. But we do need to just pick a few points. And again, pick easy points. So I'm going to pick 3 up here. So I'm going to get 3 minus 2, so 3 over 1. There's 3, 1, 2, 3. 4 is 4 over negative 2, 4, oops, how about positive 2 over 2. And 5, so 5 over 3, oops, how about, okay, it helps if we use the right numbers. The number is 3 for 3 halves. When I pick the number 4, I get 3 halves, so down here. And when I pick the number 5, I get 1. Okay, so we can see again it's going to approach the asymptote and approach the asymptote. G of x is actually just a stretch of the 1 over x that we did back in the last section, because we could pull the 3 out from it, so it's 1 over it. And then this is a movement of positive 2 to the right, because remember, anything inside our parentheses comes out as an opposite. So of the x, it's positive 2, and notice we just shifted our graph over 2 of them. And then 3 is a stretch that we do. But we're going to use our points to be able to come up with those. So that's all of our information we need to find on that one. Page 3. Again, we're going to try to sketch this by hand. So again, just a practice problem. 2x minus 1 divided by x. First of all, define the y-intercept. To find the y-intercept, we're going to make x 0. So we're going to get 2 times 0 minus 1 over 0, which is minus 1 over 0, and that can't happen. So there is no y-intercept. The x-intercept is when the numerator is when the numerator is equal to 0. So we're going to find the x-intercept to be 1/2. So right about there. The vertical asymptote is when the denominator is equal to 0, and there's nothing to solve there. So x is 0 is our vertical asymptote. The horizontal asymptote is based on the degree, so 2 of x, degree of 1, is equal to x, degree of 1. Therefore, the horizontal asymptote is the leading coefficient over the leading coefficient. So y is 1. So y is 1. Or 2 is a better number. 2 divided by 1 is 2. There we go. And then we need to find some additional points so we know how our picture is going to approach our asymptotes. More than likely, we're going to be down here in kind of this 4th quadrant and 2nd quadrant because they usually mirror each other. But we're going to pick some points anyways. So I'm going to pick just some points that are around it. So -3, -2, -1, 1, 2, and 3. So when I put in 2 times -3 minus 1 over -3, I get 7/3. And then I'm going to do it for the -2, and I get 7/2. I'm going to do it for the -1. Oops. And I'm going to get 3. Do it for the +1. I get 1. Do it for +2. I get 3/2. And do it for +3. I get 5/3. So when I plot these points, -3 at 7/3 is going to be 2 1/3. -2 It's going to be 3.5, 2.5, no, 3.5. 1, 2, 3.5. Oops. -1. How about this comes to 5/2? That's better. So 2.5, and then 3, and there's our connection. One, 1.5, and there's our connection. Remember, we're always approaching asymptotes and never crossing them. And you do need those arrows on there as well. So plot all of the points we find, plus some additional ones, and we should be able to move forward. Okay, let's go to the example that's on page 4. We're first going to find the y-intercept by setting it equal x's to 0. We get 0 over -2. So the y-intercept is 0. That is a point. The x-intercept is the numerator equal to 0, so x equals 0. Okay, we have that one. The vertical asymptote is the denominator equal to 0, so I can factor. So the vertical asymptote is going to be at 2 and -1. We're going to have 2 vertical asymptotes at 2 and -1. The horizontal asymptote is based that the degree of the numerator is less than the degree of the denominator. So therefore, y is 0. Keep in mind, because we have 2 verticals, the horizontal does not go between the 2 verticals. And then we're going to pick some additional points. -4, -3, -2. Let's go 1, 3, and 4. So when I plug that in, -4, -4 squared, minus a -4, minus 2, and I do that for -3, -2, 1, 3, and 4, I should get -2/9, -3/10, -1/2, -1/2, 3/4, and 2/5. So that when I go to plot these at -2, I get -1/2, -3/10, -2/9, and we see that it's approaching asymptotes in that manner. At 1, we get -1/2, so that tells me I'm going to be coming downwards towards my asymptotes and upward towards the left-hand asymptote. 3 is 3/4 and 4 is 2/5, so I'm going downwards towards my x-axis and upwards towards the y. Remember in here, the key part is that you're always approaching the asymptotes. So there's not too many ways that you can approach your asymptotes. We just get points so that it's a cleaner graph. But there's really not too many ways that you can approach asymptotes. All right. Page 5, we're going to sketch the graph. (2x² minus 9). Go ahead and pause the video and see if you can do it on your own at this point. Otherwise, when you come back, then I'll be able to go through it. Alright, so when we plug in 0, we get 9/2. So we get our y-intercept is, if you want, use a decimal there, that's fine, 4.5. Plot it. Our x-intercept is when our numerator is equal to 0. So divide out the 2 and then move the 9, square root both sides. We get our x-intercept to be plus and minus 3. Vertical asymptote is when the denominator is equal to 0. You can factor this or set it to 4 and get 2 answers. X is equal to plus and minus 2. So we're going to have 2 asymptotes. Our horizontal asymptote is based on the degree. The degree is 2x squared is equal to x squared. So the leading coefficient over the leading coefficient is 2 over 1. So y is 2. Keep in mind again, because we have 2 vertical asymptotes, the horizontal does not go in between. We're going to find some additional points. I chose -5, so you should have got 3/2. -4 is 1.2, so 6/5. And then 5 1/3, 5 1/3, 6/5, and 1 1/2. Okay, so -5 is 1 1/2, 1 1/5, so we should be able to connect our dots. How does it approach the asymptote? -1 is going to be 5 1/3. +1 is 5 1/3, so that means it's approaching both from the going upwards, kind of like a parabola shape. 4 is going to be 1 1/5, 1 1/2, so we can see how the other side is approaching our asymptotes as well. But we got to be approaching all asymptotes from all sides. So as long as we're doing that, we're okay. Alright, on page 6, we talked earlier about how a slant asymptote exists if the degree of the numerator is larger than the degree of the denominator. So here we can see that the numerator is larger than the denominator because x squared is larger than x to the first. So that means there is no horizontal asymptote. But we do have, we need to find the slant asymptote. Alright, and the way you find the slant is you're going to do longhand division, what we had done a little while back. So what we're going to do is we're going to take the denominator into the numerator, make sure we have every position accounted for, the second power, the first power, and the constant, and we divide it in. X into x squared goes 1 time x, so that we get x squared plus x. When we subtract, we switch signs. The first one goes away. X into -2x is -2. When we subtract, we switch signs. The first one goes away. Okay, so there's our longhand division that we did a few sections ago. What gives us the slant is the whole part, not the remainder. So the slant asymptote is y equals x minus 2. So up here, we begin at -2. We do our slope, 1 over 1. Oops, dashed. Our dashed asymptote. We can find a vertical asymptote because the denominator equal to 0 means x is -1. We can find x-intercepts because the numerator is equal to 0. So the x-intercept is 0 and 1. And then we need to pick some other points. But again, there's only one way you can approach these asymptotes. The asymptote is going to approach here and here, so that means it somehow had to cross the x-axis down there. And again, they're going to be diagonally from each other, so it's going to be some kind of loop down there. They're going to be across from each other. So with a slant asymptote, we have to do long division. Then we can find our vertical asymptote and we can find our x-intercept. Okay, so let's try that again on page 7. We know that it's going to be an x. There's not going to be a horizontal asymptote, but let's go through our steps down here and we'll come back up and fill up A and B. Make a y-intercept 0, so we're going to come up with the coefficient or the constant over the constant, so the y-intercept is 2. The x-intercept is when the numerator equals 0. So we get 2 and -1. The vertical asymptote is when the denominator equals 0. So x is 1. The horizontal asymptote, the degree of the numerator is larger than the degree of the denominator. So there is no horizontal asymptote. So because there is no horizontal asymptote, we need to go and do the division to find the slant asymptote. X minus 1 into x squared minus x minus 2. So we're going to get x subtract, so the first one goes away, left over is a -2. That does not go into it, therefore that's a remainder. But we don't care about a remainder when we talk about a slant asymptote. The slant asymptote is y equals x. It's only the whole part that goes into it. So y equals x starts at the origin, has a slope of 1 over 1. Okay. We can pick some additional points, but we do already know a couple, and like I said before, there's really, not many ways you can approach an asymptote. So -4 is -3.6, -2.5, 1.3. So there's really, only one way it can approach. And again, they're generally going to mirror each other. We already have 1 point there, but if we look at the rest of them, 3 gives me a value of 2, 3.3. We're going to approach, which means we can only approach the other way. So there's your final picture on that example. And our last problem. A rectangular page is to contain 48 square inches of print. The margins on the sides are 1.5, top and bottom are 1, so they give you the diagram of what all of that looks like. Keep in mind whatever's at the bottom goes to the top and whatever at the left goes to the right. So what we need to know is that all the way across we have our x value. Here's our x value. And then we're going to add 1.5 and add 1.5. So that's really x plus 3. Okay. Now our y value, here's our y value. We know that that is 1. Top and bottom are both 1. So that's y plus 2. What should the dimensions be? Well, that's going to be our length and our width, and it's going to be based on area. So we know area is x times y. We know it's 48 square inches because it told us that area is square inches means area. Therefore, 48 is our area. And so we're going to solve for y. We're going to make y 48 over x. Alright, so the other thing we know about area is that we know area, it's not just x times y, it's actually x plus 3 times y plus 2. Well, because we know what our y value is, we're going to substitute it in. We're going to do some distributing. So distribute the x and then distribute the 3. Okay. We can now combine some like terms. When I combine like terms, I'm also going to get rid of that x. So I'm going to multiply everything by the x, so I get rid of that denominator. And then I'm going to combine the 48 and the 6. So here I'm going to get 2x squared, multiplied by x. When I multiply 48 and 6, I get 54. I get 54x. And then 144 over x and x cancels, leaving the 144. All over x, because we're not multiplying it over here to the a, so we have to get everything that common denominator. Alright, so now we have our vertical asymptote. We get x is 0 because that's our denominator. Horizontal asymptote, we have x squared is larger than x, so it's none. Which means we do have a slant asymptote of x into 2x squared plus 54x plus the 144. When I divide into that, I'm going to get 2x. Everything else is going to come down. Then we're going to get 54. Switch signs. And x is not going to go into 144, so that's our remainder, which we don't care about. So 2x plus 54 is our slant asymptote. So if I go and try to put in our information here. Alright, when I look at this graph, I know that I have the vertical asymptote, my x-axis. Somewhere up here I have 2x plus 54 is my other slant asymptote. And I'm going to use my calculator to kind of just do a really quick sketch of what this equation would look like. Alright, the equation that I'm going to punch in is going to be what I came up with my area, the 2x squared, 54x, 144, all divided by x. And when I graph that, I did have to change my window so that I could see all the components. And we see that here's this slant asymptote because we can see that our graph doesn't cross that point. So just very little. We're not looking for anything specific here. We know that it's going to approach our asymptotes in this bottom half, and we know that's going to approach our asymptotes in this top half. When I'm looking for is the dimensions, so that's the minimum amount. Well, this is going to be that piece that I'm interested in. So if I use my calculator here and do second calculate, find a minimum, I want to make sure that my spider is up on this top half, and as long as I'm to the left, I can then move to the right, and the calculator is going to give me that point, and we see that that point is when our x value is 8.5. So when I put this up here, what does my dimensions have to be? Well, the dimension has to be 8.5 plus 3, so 11.5. And then the y, when I put this x value over into here, y plus 2, well, y is 48 over x. So 48 over 8.5 plus 2. 48 divided by 8.5 plus 2 gives me 7.6. So what does my dimension have to be? It has to be 11.5 and 7.6 inches. All right, and then that will conclude 2.7.